So now we're going to calculate out power of the source equals the power of the sink, where power of the power sources equals power taken up by the system. And so we're going to first check out the power of the independent source. The independent, remember, doesn't depend on anything else in the circuit, and that is our 10-volt source. So power equals current times voltage. Power equals voltage of 10 volts times the negative 1.67 current, which we figured out down there, which is the IS, because IS is going around there coming out of the source. So that's going to equal minus 16.7 watts. Again, we're going to have power of the dependent source, which is the one on this side. Power of the dependent source equals 3IS, which is our voltage, times our negative I0, which is our current. And so for that, if you solve 3IS and IS equals that, we're going to have 5 equals minus 1, so therefore it's going to be 5 watts. So if we go to then our sinks, we're going to have our power of the 6 ohm resistor. Power of our 6 ohm resistor, which is over there, is going to equal the current, which is 1.67, which we solved of IS, squared times 6. Because remember, power equals IV, V equals IR, so we can substitute that out to make it power equals I squared times resistance. Anyway, that's going to be 16.7 watts. We have our power of our 2 ohm resistor, which is up here, and that's going to equal 1, because our 1 amp, our I0 is 1, squared, because there's 2 of them, because it's squared. And then we have our resistance, which is 2 ohms, so we're going to get 2 watts. Then we also have our power of our final resistor, which is 3 ohms equals power. Again, we're going to have 1 amp of current. It's going to be the same as there because there's no node, there's no branching or anything. And then we're going to have that multiplied by the 3 ohms resistance, and that's going to equal 3 watts. And when you add these up, 16.7 cancel, 5 cancels with the 5, so we've proven that these are essentially equal.